So in this video, we are briefly going to discuss about basically how does an airplane work. Airplanes are an engineering marvel, but it is kind of hard to understand their overall functioning. From the way airplanes generate lift to their air conditioning system, we are going to discuss them all in this video. The first and the most basic question that arises is that how does a plane fly in the air? Well, the answer to that question is pretty simple, but still it is a very common misunderstanding among people that the engines are responsible for lifting the planes from the ground, which is not true. Engines are only responsible for accelerating the plane in the forward direction. The wings of the plane provide the lift necessary to take off. This is an airfoil. This is the cross section that is used in the wings. Its shape is designed such that when wind passes over it, it has to cover a slightly longer distance as compared to wind passing below the wing. Due to this, the wind passing over the wing has a higher velocity relative to the wind passing through the bottom. When air passes at a higher velocity over the top, it creates a low pressure area above the wing. On the other hand, wind passing at a lower velocity at the bottom creates a higher pressure at the bottom area of the wing. Due to this pressure difference, a force is generated in the upward direction, which is equal to the pressure difference multiplied by the surface area of the bottom side of the wings. Engines are without a doubt the most important, critical and complex part of the plane, which makes them understanding quite difficult. But again, the concept behind working of these masterpieces is simpler than you think it is. Jet engines are of various types. Different types of engines are used in different types of planes, all of which fulfill different use cases. However, for the sake of simplicity, we are going to focus on the engines used in major commercial planes, which is the turbofan engine. All jet engines work on the Brayton cycle, which is a thermodynamic cycle just like Otto cycle and diesel cycle, which are used in petrol and diesel engines respectively. In the above graph, the inlet of air is done at point A, following which an isentropic compression is done first in diffuser and then in the compressor till point 2. Since no process could be perfectly isentropic, the isentropic efficiency of the compressor is considered, due to which instead of reaching point 1 and 2, we reach point 1 dash and 2 dash. Now after compression, the combustion of air-fuel mixture takes place, which is considered to be a constant pressure heat addition process. This hot air is then allowed to expand first in the turbine and then in the exit nozzle, which again account for isentropic efficiency with point 4 dash and 5 dash. After this, the air is released into the atmosphere at high velocities, which produces thrust. However, for the sake of simplicity and to help us analyze the cycle, we consider this cycle to be a closed cycle and assume that the exit air is again cooled in a constant pressure heat rejection process and recycled to feed to the diffuser. Most modern day airplanes use turbofan engines. In turbofan engines, only a small percentage of air is passed through the combustion chamber and the remaining air is passed through a bypass duct, which takes some air out of the diffuser and while bypassing all the other components leads straight to the back exhaust. The ratio in which this bypass is done is known as bypass ratio. This is done to make engines more efficient. These engines are responsible for the generation of thrust to push the plane forwards horizontally. These engines could be divided into 4 major sections: compressor, combustion chamber, turbine and nozzle. The compressor is responsible for, as the name suggests, compressing the inlet air coming through the diffuser, which increases its pressure and temperature. After the compression stage, the compressed air is mixed with fuel at a specific ratio and this air-fuel mixture is then combusted at constant pressure, which further increases its temperature. This air is then allowed to expand in a turbine. This turbine is also responsible for powering the compressor and the electronic components inside the plane. After expansion in the turbine, this air is further allowed to expand in a nozzle, which also increases the exit velocity of the air. This high speed exit jet of air is what is responsible for the generation of thrust. Now, maybe the question regarding the working of a plane's AC has never crossed your mind, and I don't blame you, but stick with me here. I think that the working of a plane's air conditioning system is quite interesting. We already know that the engines of a jet work on the Brayton cycle. Well, the air conditioning system of a plane works on the exact reverse of that cycle, which is known as reverse Brayton cycle or Bell-Coleman cycle. In this cycle, the intake of air takes place as point 1, following which an isentropic compression of air takes place. Now, this is followed by a constant pressure heat rejection process, which is in contrast to the constant pressure heat addition process that used to take place in the Brayton cycle. After this, air is allowed to expand in a turbine, which further reduces its temperature. This air is used to cool the cabin. This cycle is also an open cycle, so for the sake of simplicity, we consider it to be a closed cycle by connecting the points 4 and 1 by a constant pressure heat addition process. Now, conventional air conditioning systems require separate compressor, but in airplanes a separate compressor is not required as we can use the compressors inside the engines. What is done here is that some compressed air is taken from the compressor and is cooled with the help of atmospheric air. This lowers the temperature of the pressurized air to ambient temperature. This air is then allowed to expand in another turbine which further reduces the temperature of the air. This cooled air is then used to cool the airplane cabin, which can be done either directly or indirectly, meaning the air could be directly released in the cabin to cool it, or the cooled air could be used to cool more air through the means of a heat exchanger. This is the most simple aircraft refrigeration system. More complex systems also exist which include bootstrap aircraft refrigeration system, regenerative system, bootstrap regenerative system. Please let me know if you would like to understand these cycles in deep. People might think that all ACs are the same, which is simply not true. There are several differences between an airplane's AC and the conventional ACs that we use in our households. The first and foremost is that both of them work on different cycles. One works on reverse Brayton cycle and the other on the reverse Rankine cycle. The airplane's AC works on an open cycle too, meaning that each time fresh air is taken in and the output air is released. However, in conventional ACs, same refrigerant is kept on recirculating through the cycle. Further, airplanes AC use air as the refrigerant, due to which this system is also known as air refrigeration system. On the other hand, conventional ACs use commercial refrigerants such as R134A, R22, etc. So that would be all for this. Thank you for watching.